More than a foot of rain fell on the suburbs east of Tokyo in a single day, and 4.5 inches of it fell inside 1 hour. This is one of the most flood-engineered places on Earth. 4,000 people still spent the night on the floor of a train station. Here is what actually happened and why it matters far beyond Japan. On Thursday, August 13, 2026, an extraordinary rainfall event settled over Chiba, pronounced Chiba, immediately east of Tokyo. Japan's Meteorological Agency, the country's counterpart to the National Weather Service, measured 13.8 inches of rain at its Chiba station, the highest one-day total there since the record began in 1966, clearing the old mark of 10.2 inches set in 1996. In 1 hour, the same gauge recorded 4.5 inches against a standing hourly record of 2.8. At 11:40 at night, the agency issued a Level 5 heavy rain special warning for the town of Shirako, pronounced Shi-ra-ko, then extended it across roughly 20 municipalities, including Chiba City, Ichikawa, pronounced I-chi-ka-wa, and Sakura, pronounced Sa-ku-ra. It was the region's first ever, and a parallel Level 5 warning went out for landslide risk. The regional government confirmed 4 deaths on Friday. Later tallies compiled from individual cities put the number at 8. That figure is provisional. How does a summer rainstorm put a foot of water on a modern city in half a day? 3 things were true at once, and none of them require an investigation. The first was the shape of the air column. Warm, extremely wet air was streaming in off the ocean around the outer edge of a tropical system to the south, with a pool of cold air sitting on top of it. Air stacked that way does not stay stacked. Step into a hot shower in a cold bathroom, and the steam does not hang around your ankles, it goes straight to the ceiling. Over Chiba, the ceiling was miles up, and every foot of that climb squeezed more water out of the air. The second was that the storms did not move on. Most thunderstorms build, rain themselves out, and drift away, which is why a summer downpour lasts 20 minutes. But when the winds feeding a storm line up with the direction the storm travels, a new cell forms at the same upwind spot, matures as it slides downwind, and is replaced by another one right behind it. Picture the conveyor belt at a grocery checkout. The belt keeps moving, the scanner stays put, and everything crosses the same square foot of counter. Japanese meteorologists have a name for the band this produces, Senjo Kosui Tai, pronounced Senjo Kosui Tai, and it is the signature of the country's worst rainfall disasters. Whether that is what formed here will come out in the post-event analysis. The third has nothing to do with weather. It is arithmetic. Every drainage system on Earth is built to a number, so many inches per hour and no more. Above that number, the pipes are already full, and every additional drop stays on the surface. It behaves like a kitchen sink with the tap wide open. The drain empties at a fixed rate no matter how hard you run the faucet. 4.5 inches in an hour is far beyond what any urban drainage network is built to carry. At that point, the streets stop being streets and become the drainage system. That explains the rain. It does not explain why this stretch of suburbs went under while others nearby did not. Chiba sits on flat, low ground along the eastern shore of Tokyo Bay, and it built out fast in the second half of the 20th century as the Tokyo metro area spread east. Fields became roofs, parking lots, and pavement. Tokyo's own Sewerage Bureau has described the scale of that shift, where around half of rainfall once soaked into the ground, roughly a fifth does now. The rest goes to the lowest point it can find. In a built-out suburb, that lowest point is almost never a river. It is a road underpass beneath a rail line, a ramp into a parking garage, the dip where a street crosses a culvert. Several of the deaths in Chiba involved flooded roads and vehicles caught in rising water. The substation at Soga, pronounced Soga, that took power out across the city was not on a hilltop either. Think about your own drive to work. There is one point on it lower than everything around it, and you pass through it without noticing. In an event like this, that point fills first. It fills fast, and it fills in the dark. So did the warning system work? Partly, and the gaps are the instructive part. Japan's alert scale runs 5 levels, and level 5 is not an early heads-up. It is the tier reserved for conditions the agency already considers extraordinary, and it went out at 11:40 at night. By then, the rain had been falling for hours, and the roads people would use to leave were the problem. Timing made it worse. This landed in Bone Week, one of the busiest travel periods on the Japanese calendar, and the rail network was carrying holiday crowds when it stopped. Thousands were stranded overnight at Narita, pronounced Na-ri-ta, the region's main airport. What worked came after. Japan's ground self-defense force, the military in a domestic disaster role, sent buses and moved 4,000 people out of Soga Station. By 6 in the morning Friday, more than 7,000 people were in shelters at 359 sites. But it's worth being straight about the limit. No emergency response drains 4.5 inches of water per hour. The rain stopped because the weather changed. Residents described a shift measured in minutes. Water crossing the curb, then covering it, then nowhere left to put a car. Around 80 homes took water inside, and more than 200,000 people were told to shelter or leave. The detail that says the most about the night is the station. Soga is an ordinary commuter stop on a line that also carries visitors toward Tokyo Disney, and 4,000 people could not get out of the building. Power failures dragged on because the equipment that fixes them was underwater. The utility pointed to the flooded substation and damaged lines, with more than 20,000 households losing electricity, most in Chiba City. Is this happening more often, or are we just watching more closely? There is a real signal, and there is also a measurement problem. Start with the design numbers. They are concrete. New York City's stormwater system was built for about 1 3/4 inches of rain per hour. When the remnants of Hurricane Ida crossed the city in September 2021, Central Park recorded 3.15 inches in a single hour, the wettest hour ever measured there, breaking a record set 10 days earlier. 2 records in 10 days, in a place with more than a century of data. Now, the problem. In the summer of 2022, the United States logged several events labeled 1 in a 1,000 year within weeks of each other. Researchers who later reworked the St. Louis storm put its return period closer to 530 years, not 1,000. The label moved by half, and nothing about the rain changed. It moved because of how the region was drawn. So, the honest version, hourly rainfall records are falling in places with long records, and the statistical labels we attach to them are less solid than they sound. So who else lives in this? The setup that flooded Chiba was not exotic. It takes 3 things: a source of very wet air, a storm that stalls, and a lot of pavement. New York has all 3. Ida's rainfall rate overwhelmed the sewer system in hours, and 11 people drowned in basement apartments inside the city, not in a river floodplain, in living space below street grade. The National Weather Service issued a flash flood emergency for all 5 boroughs for the first time ever. Dallas-Fort Worth has all 3. In August 2022, parts of Dallas took more than 13 inches in 12 hours, and the airport gauge logged 9.19 inches in a day, its second wettest on record. St. Louis has all 3. 8.64 inches at Lambert Airport on a single July day in 2022, much of it inside a few hours, and the costliest flood in the country that year. None of those were storm surge or river floods in the way people picture them. They were drainage events in built-up places, and the water never had anywhere to go. If your address is not on a flood map and you have never thought about this, you are exactly the person these events keep surprising. You cannot change how much rain falls. 4 things are worth your time, ranked by what they buy you. First, look up your address on the Federal Emergency Management Agency's Flood Map Service Center. 10 minutes, free, and it tells you whether you sit in a mapped flood zone. But understand what it does not tell you. Those maps are drawn mainly for rivers and coasts. Urban drainage failure, the kind that put water in Queens basements and Chiba underpasses, often happens well outside a mapped zone. A clean result means you are outside one risk, not this one. Second, find the low point on the routes you drive every day, the underpass, the dip, the culvert crossing. Decide now what you do instead, because you will not decide well at night in the rain. The National Weather Service is blunt. 6 inches of moving water can knock an adult off their feet. A foot of it can float most vehicles, and most flood deaths in the United States happen in cars. Third, get what matters off the lowest floor. The furnace, the electrical panel, if it can be raised, documents, photographs, the things you cannot buy again. That is an afternoon. And fourth, the one almost nobody does in time. Standard homeowners insurance does not cover flood. It is a separate policy with a 30-day waiting period before it takes effect. Buying it when a storm is in the forecast accomplishes nothing. Ready.gov and the FEMA app carry checklists for your hazard. As of Friday, the rain had eased, crews were still restoring power, and officials warned that saturated ground would keep landslide risk elevated for days. The count of what was lost is not finished. The lesson underneath this is not about Japanese engineering, which is among the best there is. It is that every drainage system on Earth is built to a number, and rainfall does not know the number. When the rate goes above it, the water goes where gravity sends it, and gravity has already picked the low spot on your street. Go find yours. Tell us where it is.